Okay, Bismillahirrahmanirrahim. Let's discuss similarity. Now, there is a very small difference between the similar and the congruent shapes, and then we'll be focusing on the triangles later on. Okay. So now, what happens in similar triangles is, first of all, we need to go back to the congruent triangles. Like if there is, I'm not drawing that. Okay, if there is a triangle ABC that is congruent to the triangle PQR, then if these are two congruent triangles, then angle A would be equal to the angle P, angle B would be equal to angle Q, and angle C would be equal to angle R. Okay, all these three angles are equal, corresponding angles are equal. And then the side AB would be equal to the side PQ. The side AC would be equal to the side PR, and the side BC would be equal to the side QR. Like the six corresponding measures, they are exactly equal to each other. Okay, so congruent means they're same. uh, Here, when you have two similar triangles, for instance, suppose there's a triangle LMN, triangle LMN. Now, this is the symbol for the similarity. That is similar to the triangle, um, let's say it is similar to the triangle XYZ. Now, if these two triangles are similar, first of all, you will see that their corresponding angles will be equal. Angle L will be equal to angle X, angle M will be equal to angle Y, the angle N will be equal to angle Z. Okay, it's same here. You had all the three corresponding angles equal, and here the corresponding angles are also equal. Now, what is the difference then? The thing is that now the sides, they are going to be proportional. The sides are going to be proportional. Let me write them down and then I tell you. Like, what do we mean by proportional? Like, if I compare the side, in this case, in the triangle ABC, which is congruent to the triangle PQR, the side AB over the side PQ, that will be equal to the side AC over the side PR, and the side BC over the side QR, they will all be equal to 1 because the sides are exactly equal to each other. But in this case, the side LM over the side XY will be equal to the side ln over the side xz, that is equal to the side mn over the side yz. And this time, this will not be equal to 1. This can be any other number, any other fraction, positive number, but that will not be equal to 1. If it's equal to 1, that means, for example, if this, let me just draw this quickly. For example, you have a triangle here. This is your A, B, C. Let's say this is 5, this is 6, and this angle is 30 degrees, okay? And in the triangle PQR, you have something like this. Suppose this is your P, this is your Q, this is your R, and this angle is 30 degrees here, okay? So you'll see that if this AB is 5, so this PQ will also be 5. If AC is 6, this PR will also be equal to 6. So the corresponding sides are exactly equal to each other. Now what happens here? Now suppose this is your triangle LMN. This is the triangle LMN. Suppose this is 3, this is 4, and this one is, let me write here, um, let's say this is 6 over here, okay? And this angle is, let's say this is 100 degrees over here. And there is another triangle over here, which is the triangle XYZ. Now, suppose the triangle XYZ is going to be like this. Um, okay, so this is your X, this is your, let me just draw this a bit correctly, uh, like this is your um, P here, this is your, sorry, this is X, sorry, this is your X, this is your Y, and this is your Z. The angles are going to be same. The angle Y is going to be this M, and Y, they are corresponding. So this is going to be 100 degrees. But suppose if this LM is 3, then this is going to be 6. If this MN is 4, then this is going to be 8. Okay. And if this ln is 6, you can guess this is going to be 12. So now the sides, the corresponding sides, they are not equal, but they are proportional. They are proportional. You can write down in your notes that in congruent triangles, the corresponding angles and the corresponding sides, they are all equal to each other. The corresponding angles and the corresponding sides of two congruent shapes or two congruent triangles, they are exactly equal to each other. But in case of the similar shapes, the similar triangles, the corresponding angles, they are still equal. I'm repeating, the corresponding angles are still equal. I can recall a question from the past papers here. Um, um, a few years ago, there was a question that this is A, this is B, this is C. This angle was given as 15 degrees. This was given as, let's say, 7. This was given as 12. And then there was another triangle drawn here that is, let's say this was the triangle PQR. This was given as 21. This is as 36. And this angle was given as 45 degrees. And then the question was asked that if these two triangles are similar or not. Now, students, when they're attempting the question in the paper, they say, oh, yes, 7 3 times is 21, 12 3 times is 36, and then say, oh, yes, 15 3 times is 45. So they think that these two triangles are similar. What do you say, people? Are these two triangles similar? Why not?
Because the angle still stays the same.
Yeah, the angles, the corresponding angle has to be the same. If it is 15 here, this should be 15. Now, suppose if this was 45, even then these two triangles are going to be
Congruent.
similar to each other. Okay, so when two shapes are similar, then the corresponding angles, they have to be equal, while the corresponding lengths have to be proportional to each other. They have to be proportional. Like you see that 7 ratio 21 is same as 12 ratio 36. Now suppose if we are given that this side over here is 10, can you guess what is going to be this side then? Yeah, that will be 30, because the same ratio is maintained
Congruence,
here.
yeah.
So this is 10 times 3. So this would be 330 over here. Okay. So I'm repeating this again and again, that when you have two similar shapes, their corresponding angles still have to be same, but their corresponding sides have to be proportional. Now, what are the cases of similarity? First of all, you should recall the cases of congruence in triangles. Cases of congruence. Uh, the When you have to prove two triangles congruent, there have to be at least one pair of equal corresponding sides. So the cases of congruence are going to be side, 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 angle, side, or this can be side, side, angle, or it can be angle, side, side. Okay, why I'm putting the third s over here. Okay, and then it can be angle, angle, side, or angle, side, angle, or side, angle, angle. And then there is a fourth rule, that is RHS, that is right angle, hypotenuse, and side. This is for the right angle triangles. Okay? Now, we cannot say if two triangles are congruent if you just have three angles of it. This is like, angle, angle, angle. This does not work in this case, like cases of congruence. So you must have at least one pair of corresponding sides if you want to prove two triangles, if they are congruent to each other or not. Now, the cases of similarity, cases of similarity. The very first case of the similarity is angle, angle. And you can put the third angle as well. If you're sure that the three angles, in fact, like two, obviously, if two angles are equal, the third pair of angles is automatically going to be equal. Okay. So if you prove that two angles of a pair of triangles, two corresponding angles, they are same, they're equal, then you can easily say that these two triangles, they are going to be um, congruent to each other. And if you have two sides and one angle here, then these two sides, they have to be proportional. And if you have all the three sides, then you can say that if they are proportional, it means that the the two triangles are going to be similar to each other. Now, in when you have to prove two triangles to be similar, this one is a very important case. That is two angles. When you have two angles equal to each other, let me tell you how we have like what are the typical cases of similarity. Okay, typical cases of similarity. Acha, I think I should do that in the next class. Before we go into the typical cases of similarity, let me take you to the exercise and try some questions from there, and then we'll come back to this maybe in the next class. Okay. So here is this exercise, guys. This is the exercise 8B. Now it says, given that the triangle ABC is similar to the triangle PQR. Now, guys, remember when you are given that two triangles, if they are similar or they are congruent, and the names are given to you, then it means that more than 50% job is done because you already know that what angles and what sides are corresponding to each other. Like this A is going to correspond to this P, B is going to correspond to Q, and C is going to correspond to this R. Okay. So it says we have to find the unknown things over here. So if you have to find the angle Q from here. So since you see B is corresponding to Q, can you see B is corresponding to Q? So we know that B is 90 degrees here. So here this Q would be 90 degrees. Your X is 90 degrees. Okay. Similarly, this C corresponds to this R from here. Okay. So if this R is 35, then this Y is going to be 35 degrees as well. So, through these two, you can get this angle as 55 degrees. Okay? Acha. And similarly, you can try the part B and C. And let me do this B part for you. It says here the triangle ABC is similar to the triangle PQR. So if this is 118, this is 118 here. So 118 plus 28 is going to be 146. So this is going to be 34, Hannah. So this angle X is going to be 28. So this is how you can find these unknown angles over here. Now, this is interesting here. This is, you are given all the three sides of the triangle ABC, and here these two sides are unknown. So we know that the triangle ABC is similar to the triangle PQR. So AB over PQ. Good students always write these ratios. Like AB over PQ would be equal to BC over QR. That is going to be equal to AC over PR. Now your AB is 18, okay. Your PQ is 6, fine. Your BC is 12. Your QR is X. And then your AC is 18. And did I write AC again? What was AB? Oh, AB was 10. Oh, I was writing this wrong. Nobody told me. AB was 10 here. AB is 10, PQ is 6, and then we had BC, that is 12, and then its corresponding is QR, which is X, and then you have AC 18, and its corresponding is going to be QR, which is going to be, sorry, AC is corresponding is PR, which is going to be Y over here. So we can equate these two to find X. So 10 over 6 is going to be equal to 12 over X. So you have 10x equal to 72, and your X is going to be 7.2. Similarly, we can equate these two to get to this Y. Okay, so this is going to be 10y equal to 6 18s are 108, 6 is 48, yeah, Hannah, this is 108. So your y is going to be 10 point, I'm doing this mentally, 16 eights are 108, no? Okay, so this is going to be 10.8. Now, guys, similarly, like we're just saying that if we given that two triangles, they're similar, then we're putting their corresponding sides ratio equal to each other and finding the um, unknown sides through the ratio. Okay. As I look at this triangle A, B, C, D, can you try this in the same way? Acha, now this D part, we are given that the triangle ABC is similar to the triangle PQR. Now, when you given that two triangles are similar, then you don't need to go again and again to the this given shape. Just write that AB. This is the safest way of solving these problems. AB over PQ, that is BC over QR, that is equal to AC over PR, because the two triangles, they were similar. So we have put the corresponding sides ratios equal to each other. Now your AB is 12, your PQ is 8, your BC is 7, and your QR is Y, your AC is X, and your PR is 10. Now, these are all equal to each other. Now, let's put these two equal to each other and find this. You can simplify this for threes are and for twos are. So now this is,
PQ10.
yeah,
10. PQ10.
P,
Q10 centimeter.
Q, PQ is 10. So what did I write here?
8.
Oh, PQ is 10.
Yes.
Why didn't you tell me before this?
PR8.
Okay. Uh, this, they're saying that PQ is 10. So this is 10 here. So let me write this again. Just 1 minute. Okay. So we had AB was 12 and PQ was 10. BC is 7. QR is Y, AC is X, and PR is it. Okay, now fine. I'm going to simplify this with 2 6 times to 5 times. Okay, now when I put these equal to each other, I have 6y equal to 35. So y is 35 over 6. That is approximately 6, I think. I'm doing this mentally, okay? And then this one equal to this. So we have 5x equal to 48. So x is going to be 9.6. Hmm? 5 nines are and 5 6. Yeah. So x is going to be 9.6. So this is how you find the unknown sides when you're given the two triangles are congruent to each other. So now look at this question number 2, bacho. He says, is triangle ABC similar to triangle PQR? So you have to explain your answer. Now, look at this AB. If that AB is going to be um, proportional to this PQ, AB and PQ, they're given as equal to each other. Okay. Now this side AB is equal to the side PQ, and the side AC is equal to the side PR. Okay. And then we have angle A over here, which is 40. And here we have, let's find these angles quickly. If this is 40, this is going
70,
to be
70.
70, this is going to be 70, this is 50, and this is going to be 80. So, and they are neither, similar nor they are congruent. Okay. Now look at this, because he says explain your answer. So you can say that since the corresponding angles are not same, therefore the two triangles, they are not similar to each other. Now look at this. It says it's triangle DE is similar to triangle STU. Now you can either use these names over here, or you can see that you can have the ratio between the smallest and then the longest and then the medium one here. So from here, the smallest side is 3.3, and here it is 2.4. Okay. And then the longest side from here is 5.7, and here it is 3.8. You have to see, check if these two ratios are same. If they're same, then we'll check for the third, the medium sides. Okay. Now this is going to be, you can remove the decimal, and this is going to be 11 over 8. Okay. And this one is, I think this is going to be 3 by 19 threes are 57, 19 twos are. So since this 11 over 8 is not equal to 3 over 2, therefore the two triangles, they are not similar. Okay. Let's see what do we have in the next. Yeah, the third question here. It says given that the quadrilateral ABCD is similar, This is the word you have to pick, okay? To the quadrilateral this. So we have to find the unknowns here. Now, first of all, you can see the angle A from here and angle P from here. They are equal. So angle X is going to be 95. Okay. Then angle B from here is going to be equal to the angle Q here. So that is going to be 105. Let me put 105 here. Let me write 95 here. Okay. Then we have angle C coming next. So angle C is going to be equal to the angle R. So let's add all these three angles and take them out from 360. Can you do that? Those so teens are, I think that is 52. Yeah, I'm doing that mentally. You can check this. So this Y would be 52 degrees. Okay, this way we have got the unknown angles X and Y from here. And do we have to find any side? Yeah, we have to find the side Z. Now look at this PQ. Now PQ from here, this is your PQ, is corresponding to AB. Now can I write this Z over 8? That is equal to, we are given this BC. So this BC in the middle here is going to correspond to QR in the middle here. So QR is 7.2. Now remember, I have written this z in the numerator. So next time when you write the next fraction, you have to write the side of this shape in the numerator. So I'll be writing that as 7.2 over 12. So if you simplify this, you can get to this z. I think that would be 4.8 if you use your calculator. So this z will be 4.8. ठीक है बच्चों. Now, if we have to go to the this advanced level questions, for that you will have to wait till tomorrow. I'll first of all tell you about the typical cases of similarity, and then inshallah we'll do these questions. ठीक है?